Although Albert Einstein is best known for his theory of relativity, and particularly the equation E equals mc squared, it was not for this that he received the Nobel Prize in Physics in 1921. Instead, it was for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. The photoelectric effect can easily be demonstrated using a gold leaf electroscope. When the electroscope is charged up, electrons move onto both the zinc plate and the gold leaf. As like charges repel each other, the leaf rises. Notice that the electroscope case is positively charged. What happens when you shine light onto the zinc plate? Even in very intense light, there is no effect. What would happen if you shine ultraviolet light onto the electroscope instead of visible light? Compared to a visible light photon, a UV photon has a shorter wavelength and a higher frequency, and carries more energy. The UV photons landing on the plate cause the electrons to be emitted, so the electroscope discharges. The electroscope case remains positively charged. What happens when you shine more intense UV radiation onto the zinc plate? The number of electrons emitted per second is proportional to the intensity of the incident radiation. Einstein's explanation of this effect was revolutionary. He realized that removing an electron from a metal surface requires energy. This energy, called the work function phi, must be delivered in a single packet, or photon. Photoelectric emission cannot occur unless the energy of an incident photon, hf, is greater than the work function phi. Any spare energy given to the electron is carried away as kinetic energy. It is this explanation that earned Einstein his one and only Nobel Prize in 1921. If you plot a graph of the kinetic energy of the emitted electrons against the frequency of the incident light, the intercept of the graph with the x-axis gives the minimum frequency for which electrons are released, from which the work function of the metal can be calculated. In summary, if you shine visible light onto the electroscope, however intense it is, none of the electrons will be emitted. However, if you shine ultraviolet light onto the electroscope, whose photon energy exceeds the work function of the metal, electrons will be emitted, even if the ultraviolet light is very weak.